Right, here we go with Cramer's rule. Cramer's rule is named after this nice guy, Gabriel Cramer. What he did was he devised another method for solving systems of equations. What we're going to do is we're going to find basically three or four different determinants, and we're going to end up and divide them. So you can kind of read through this if you want, or if you are bored, and then you can go through and solve. And then we'll do an example which makes it a little bit nicer and easier. So what we have here is you have, relative to the original system, the denominators of x and y are simply your determinant of what we would call the coefficient matrix. Whoops. Yeah, that's okay. My pen's not working so hot. What we have, what we call the coefficient matrix. And then what we're going to do is we're going to find your matrix for your x and your y. So if we have your coefficient matrix, giving this example right here, this system, we have 2, -4, -5, 3. 2, -4, -5, 3. So we're going to call this D. Now we're also going to find D sub x, and if you notice, if you're going to solve for x, what we're going to do is, instead of having 2, -4, -5, 3, these are still the same. However, these numbers change. Well, these come from your coefficient matrix, or your constant matrix, I should say. So these are your constants. And notice what gets taken out. Well, if you're solving for x, you're going to take out your x column and plug in your constants. So keeping that idea in mind, if you want to solve for your d or for y, you're going to take out your y's, you're going to put in your constant matrix there, keep your x's. And then eventually what we're going to end up doing is dividing your x over your d. So we're going to kind of skip through this. It's just a bunch of intelligent writings that you can read about if you want. And let's get into the example. So what we need to do is we need to find three different matrices here. So D is just your constant. So that's going to be the constant for, or your coefficients here. 3, 5, 4, and 3. Now D sub x is going to be where, if you're solving for x, remember you're going to take x out and you are going to insert in its place your constant. So take the x's out. So we're going to make this a 1 and a 9 instead. We're going to keep your y's. So now keep that same idea for what we're going to do for d sub y. In this case, we're going to keep your x's, but we're going to take out your y's, and in its place, we're going to plug in your 1 and your 9. So what we're going to have to do is we're going to find the determinant for each of these. So for d, that's just going to be diagonal AD minus BC, so 9 minus 20. That will give us a negative 11. Now for d sub x, what we're going to do is we're going to take 1 times 3. 3 minus 4 times 9 is 36. So we're going to have d sub x is a negative 33. And then d sub y, we are going to take 3 times 9, which is 27, minus 1 times 5, which is 5. And you're going to get d sub y is equal to a 22. So now that's the part that you've learned previously with determinants, and this next part is not going to be too bad. If we're trying to find out what x is, we're just going to take our determinant of d sub x and we're going to divide it by d. So we're going to say we have your negative 33 divided by negative 11. Your x value then is going to end up being 3. Same thing goes for y, where we're going to take your d sub y and divide it by d. So we're going to say y is equal to a 22 divided by negative 11, which gives you y equals negative 2. So your final answer, your ordered pair for your x and your y, just ends up being 3, negative 2. That is how you use Cramer's rule to solve a system of two equations. Let's put a box around this here and cut.